Hello again. So, I might as well turn cat cam off because he gone. Excellent. So last time we talked about implementing queues with an array, and I said you can use them a linked list for them. So now we're going to talk about stacks, which are kind of the opposite of queues, and we're going to use a linked list for this one. All right. So here's our test. I'm just going to from our old main, we're going to grab this assert true and put it in here. Okay, so what do we want to assert about this pop statement? What do we expect to come off of this? Well, if this was a queue, if I push 3, 4, 5, I would expect 3 to be the thing that comes out of the queue. Stacks work in the opposite manner. They're like an actual stack of things, right? When I put things onto a stack, when I'm going to take things off of the stack, I start on with the thing that I most recently put on the stack, right? I have to take this thing off of the top of the stack. Meaning that when if a queue is a first in first out, a FIFO, a stack is a first in last out or last in first out or whatever, however it helps you remember it. But basically, the thing that went in the most recently is the thing that left. It's like a really crappy. If they did this at the grocery store, it would be a nightmare, right? If you're the first person to line up, you'll get served last. Ew. But they're still useful data structures. So we're going to assert that pop equals 5 here for a successful test. Oh, no, I don't need assert. I need assert true. And then I'm going to just then I'm going to try s dot pop cout failed. Did I set this? I have IO stream using. Are you happy now? Are you happy now? Now are you happy? Oh, I don't have a semicolon. That's not good. Now you're happy. And then we're going to catch exception ex cout past. So we wanted to throw an exception when there's nothing on the stack. Okay? Seems fair. Seems nice. How am I doing on time? Think I'm good. Sorry for 1 second. All right, cool. Good. We're good. All right. So, moving on. What are we going to do now? So we've implemented a test to test. So this is the checking that there's an exception test. Make sure that it throws an exception when it's empty. So let's start again with the constructor here. So we're going to go to the constructor. We see that it's not implemented at all. Is that true? It is true. So this time we're going to use, we have an array. We're not going to use an array. We're going to use a linked list. Top. And then I think that's all we need. Then we're going to do class stack, class node. You might be wondering, why did I put that class stack at the top? It's because I'm about to say private, I'm about to make it a friend of node a friend of stack. And so stack has to be declared somewhere. So basically this first one is saying, hey, I'm gonna define a stack. And so that way node has something to refer to. Okay, that's all. And it's going to have int data, and it's also going to have it's going to have a node pointer next. Okay, we're going to make a constructor here with alt insert constructor. Do I want a next? No, but I do want data. Okay. There's my constructor. It wrote the constructor for me, but I'm going to go ahead in here and clear next. Okay. So there's my constructor. Let's go back, double check. This constructor, all right, incapacity. We're not even going to have a capacity this time. And so let's implement this, alt enter, generate definition, and we're just going to say top equals null pointer. Okay. Excellent. What? 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 What are you mad about? Why are you mad about everything? What is the error here? Insert parentheses. Oh, let's just do mtop. Oh, actually, yeah, mtop. And I should be doing that stuff over here, so I'm going to rename this to mdata and rename this to mnext. And hopefully, no data. This shouldn't take any. Oh, yeah. So mdata equals data, and see it renamed it everywhere. Nice. All right, cool. So we make a stack, we just make it null pointer. All right, great. So now we'll go back to main. What do we implement next? Push. Cool. So I'm going to click on push, control click on push. I see that it's yellow here, so it's not implemented. So I'm going to alt enter and generate a definition for it. This will be data. And then what I'm going to do is I'm going to make a new node pointer to add equals new node data. If mtop is equal to null pointer, then mtop now equals to add. Else, to add next equals mtop equals to add. So now we notice we put this phrase in both. So I could actually simplify this to do to basically reverse. So this would work, but we're gonna reverse it. Like that. So we're going to say if it's not null pointer, I'm going to have it point to whatever the top is, and then down here. And you might say, well, that's actually a legal line of code. You don't even need this if statement. We'll feel good about ourselves. So, okay, we're going to push. There's no capacity, so there's no exception to be thrown here for exceeding the capacity. So I'm going to posit that we're done. And I'm going to still just run my code. But the tests will fail. That's fine. That's fine. It doesn't hurt us that the tests fail. We expect them to fail. And now we're getting some errors. That's great. Stack S10. Oh, okay. So, great. This doesn't need an argument anymore because we're using a linked list. Cool. What else you got for me? Ooh. And there's some undefined references. All right. That's cool. Also, we never wrote our destructor over here. That's fine. Done. Okay. So we still have some more undefined things. That's fine. So we have push, so let's implement pop. Not Windows key. All right, pop is going to take the thing off the top, right? So what we're going to do is we're going to say node star to return, or actually we're just going to say int to return equals mtop data. Then we're going to node pointer to delete equals mtop. Then we're going to say mtop equals mtop next. Then we're going to delete to delete. And then we're going to return to return. So what we're doing is this first line, we're saving the value that's currently on the top off to the side so that we can return it later. Then we're getting a pointer to the top node on the stack so that we can delete it later. Then we're moving the top pointer down one on the stack so that we can safely delete what was on the top and then return the data that was on top. Okay? So this is all some manipulation that we're doing so that we can safely delete the element that's on the top. If you remember in the array implementation, we didn't have to do any deletions because we just moved around the start and end pointers or indices, which enabled us to just kind of reuse that array spot. We were just ignore it if it wasn't there. But because this is a linked list, we have to actually go through and delete these things. And in the spirit of going through and deleting these things, let's write this. So let's implement it, generate definition. I don't know why this is a virtual function. It always does this. No. So we're going to implement stack, and that'll just be delete mtop, which means that we need a good node deletion. So I'm going to do alt insert destructor, which takes me to destructor, and it'll be delete m next. All right, let's run it. That's all there is. Pass. Nice. Segfault. All right. What? Data in next is null. Well, huh? See, this is when I wish I was live streaming this, because I could just look and you guys would be like, oh, it's that, dummy. Why is this a segfault? Wait, the first popped worked. All right. So I'm going to, again, let's demonstrate the usefulness of a debugger. We're going to stop. We're going to run it. And let's look at our stack. We have mtop next is 4, next is 3. Okay, so now we're going to step into. So to return is the data on the top. All right, then, so that's 5. Then to delete is the top, which is a node with 5 in it. Makes sense. Mtop equals mtop next. So next should be 4. So this top should turn into, it should go from 4 to 5. Or 5 to 4, rather. Then I'm just delete a node. Oh. Whoops. Okay, we don't want to delete the next node. Whoops. Actually, I'm just going to delete this. We don't even need one now because it's just going to do a standard delete. Standard delete. And we'll just do this. So we'll just do the cur equals mtop while cur equals, or while cur doesn't equal null pointer. We could also just say while cur node to delete equals cur equals cur next delete to delete. Couldn't use any fancy recursion here. Because I don't, when I delete one, so what was happening if you didn't catch that? I wrote the delete for the node to delete everything after it, but the problem was when I was popping, I was deleting one node and then everything after it, and there wasn't any data there. So I was making the segfault mistake of trying to manipulate data that I had already deleted, which is the equivalent of like trying to go back to the classroom analogy, trying to play with a toy that you've already given back to the teacher's toy chest, right? It's trying to reach back in there and like, oh no, sorry. So I'm guilty of that this time. Whoops. 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 So we all make mistakes, including someone who's been teaching this for 3 years and coding for vastly longer. Excellent, excellent, excellent. Pass, pass, pass. We have a seg fault on the pop. Oh, right, because we don't throw an exception, guys! See, look how nice debuggers are. It seg faults and it tells me right where it's seg faulted. And so I can figure it out immediately. If top equals null pointer, throw an exception. Yeah? Are we using, how about this? What? Alright, now it's imported. See? Whoop. Cool. Let's try this again. I'm going to remove this breakpoint and just tell it to bloop down to the end, and we'll look at the console. Pass, 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 pass. There's our stack with a linked list. Congratulations to us. We are championesses. So have a good day. That's it for this recording. Bye.